Here are your notes for Geometry, Chapter 3, Section 2, found on page 52 of your workbook. Now, in Section 3-1, we were talking about parallel lines, and when a transversal intersects parallel lines, we have all these great angles that are congruent. In this lesson, the big idea is we can flip that around. We can say, if I know the angles are congruent, then, ta-da, the lines must be parallel. Which should sound a little bit familiar. That should sound like the idea of a converse. So let's have a little trip down memory lane from Chapter 2, Section 1, from page 34. You don't have to turn to that. I have reproduced the important stuff here. And what I really want to zoom in on is conditionals and converses, because we're going to put those to use in this section. So a conditional statement is an if-then statement. The hypothesis follows the if. And remember, if is not part of the hypothesis. The conclusion follows the word then in this if-then statement. This word is not part of the conclusion. Truth value, true or false, not worried about that right now. Converse. Well, how did we make converses from conditional statements? Well, if this is a conditional statement, the word if, then the hypothesis, the word then, and a conclusion, the converse takes the conclusion and puts it after the if. The converse takes the hypothesis and puts it after the then. So now, let's also take a look at the material from section 3-1 on page 49. Again, you don't have to turn there. I've reproduced it here. This is what your page 49 should say. Postulate 1. If, it must be a conditional statement because I got an if and a then. So here's the hypothesis. Transversal intersects two parallel lines. So here's my hypothesis in yellow. Then corresponding angles are congruent. So what would that be as a converse? I keep the if. If I can keep the if. I keep the if. I keep the then. Now I'm going to put after the if the conclusion from my original statement. If corresponding angles are congruent, then, here's my hypothesis, then the transversal intersects parallel lines. Now we're going to shorten that, I guarantee you. We're also going to spell it right. Parallel lines. So here's how we're going to shorten it a little bit. If corresponding angles are congruent, then, let me write it out, then the lines are parallel. Because in all of these situations, you're going to see a transversal and you're going to see these lines. And now we're trying to prove that it's the lines that are parallel because we will be given information about the angles. So here are the rest of these theorems. If transversal intersects parallel lines, then alternate interior angles are congruent. The converse would be if alternate interior angles are congruent, then the lines are parallel. So we can adjust the grammar a little bit, but the big idea is we're in section 3-2 today, we're going to be making converses of all of these angle theorems. So here we go. Here it is. Finally, page 52. I'm going to zoom out so you can see all of these all at once. pause the video while you copy these statements into your notes. And it's just like what we thought. If two lines in a transversal form, I know that's a lot of lingo. We're going to leave that out pretty soon. If corresponding angles are congruent, then the two lines are parallel. And there it is again. If alternate interior angles are congruent, then two lines are parallel. So these are just the converses of all the things that you were working on in section 3-1. So here are the things that we know. In postulate 3-2, I've got two lines in a transversal, and some these arcs are showing me that the angles are congruent. So I am given that angle, hang on, sorry. There we go. I'm given that angle 1 is congruent to angle 2. And now that leads me to a conclusion that the lines are parallel. Which lines? Well, if 1 and 2 are corresponding angles, then this is my transversal, and it's L with M. So here's my cursive L and an M. So those are the ones that are parallel. Now we're going to do converse of alternate interior angles theorem. And now we're going to be told that the alternate interior angles are congruent. Now we can make the conclusion that the lines are parallel. So if I know that angle 1 is congruent to angle 2, so there's my given, then my conclusion, first of all, let's highlight that. Angle 1 congruent to angle 2. Those are the alternate interior. So this must be my transversal, and here are my parallel lines. L parallel to M. Do you know that this is the symbol for parallel? It should be two long lines that are parallel. Go figure. Okay, here we go. Converse of same side interior. So now I've got 2 and 4. Back up on this same diagram. Angle 2 with angle 4. Those make same side interior angles. So here's my transversal, and here are my two lines that magically are parallel, because I knew that the same side interior, same side interior are supplementary. Not congruent. Converse of alternate exterior angles theorem. Have you noticed that when we do same side angles, I get supplementary stuff, and when I do alternate angles, I get congruent stuff? Okay, let's keep going. So the converse is going to be like this. If I have angle 3 congruent to angle 5, those make alternate interior angles with this as my transversal. So line L has to be parallel to line M. Do you notice a pattern here? Yep, take a guess. 3 and 6 are supplementary because I'm doing same side exterior, then L is parallel to M. Now, here's a new thing, a flow proof. This is the third style of proof that you could use. A flow proof looks like this. You are given the given, and you're also told what you're trying to prove. And flow makes you think of flow chart. So here it is. You're making the statements here, and you're putting the reason underneath it. And once you have enough reasons to support another conclusion, you draw your arrows to that conclusion, use your logic, your reasoning underneath, and then finally the thing you were trying to prove with the reason underneath. So, can you name the other two kinds of proofs? And which one is Mrs. Mitchell's favorite? Yes. The two-column proof. So here are the things that you need for the top of page 53. Definition of flow proof, and that these describe the picture right up here. Now let's try some examples of using these converses to arrive at some conclusions. Page 52, example 1. We're going to use postulate 3-2. Postulate 3-2 is the converse of corresponding angles postulate. So if we use the diagram, we're going to talk about angle 3 and angle 2. So it's asking us which lines, if any, must be parallel if 3 and 2 are supplementary. So now let's fill in some boxes here. If it's given that 3 and 2 are supplementary, so the diagram shows that angle 4 and angle 2 are also supplementary. Here's 4 and 2 also have to be supplementary, because we know that adjacent angles that form a straight line must be supplementary. Now here, supplements of the same angle are congruent. Whoa, what does that mean? G-R-U-E-N-T. Supplements of the same angle. Well, that means if we've got the yellow angle and its supplement, I can come over here and draw another angle. No, I need more room. I'm going to keep the yellow angle, but here's where I'm going to make its supplement. Look at that. I got a straight line here, and now I've got a supplement. So the two blue angles, those are different angles, but they're congruent because they are both supplementary to the yellow angle. So that's what that meant. Supplements of the same angle are congruent. And there's your theorem. So now that means we can say that angle 3 is congruent to angle 4. Well, where did that come from? Since 2 was a supplement to 4 and 3 was a supplement to 2, that must mean that 4 and 3 are congruent. And you're sitting there saying, Mrs. Mitchell, I knew that. They're corresponding angles. So we're actually proving how we got to this converse of the corresponding angles theorem. Because angle 3 and angle 4 are congruent corresponding angles, this line EC and this line DK have to be parallel. Incidentally, CK was the transversal. We didn't even need this line over here for any of it. So now I'm going to write that EC was parallel to DK by the converse of corresponding angles postulate. So we actually proved this thing with the algebra that we did there. Now then, let's continue. So example 2 on page 52. Find the value for x which makes L parallel to M. So I've got the diagram right here, and I need to make sure that L is parallel to M. The labeled angles happen to be this one and this one. Those are called alternate interior. And so, if these are parallel, then the alternate interior angles are congruent. That was what we did yesterday. So now their measures have to be equal. So I can practice my algebra now. And here's what the equation looks like. They're trying to get you to fill in 5x here and the 14 here. So now 5x minus 66 equals 14 plus 3x. Add 66 to both sides and you're left with the 5x equals 80 plus 3x. There it is. Added 66 to both sides. Now, I should start over here. So I've got 5x equals 80 plus 3x. So now I'm going to subtract the 3x from each side, and I'll be left with 2x equals 80. Now I'll divide both sides by 2, and x equals 40. So, as long as x is 40, for this diagram, the lines are parallel. Lastly, use the diagram from example 1, which I've reproduced for you over here. Which lines have to be parallel if 3 is congruent to 4? Where's 3? Up here, and 4. This should feel a lot like the problem that we already did on the previous page. But if 3 is congruent to 4, then this is the transversal, and these are the parallel lines. So we'd have EC parallel to DK. And why? It's the converse of the corresponding angles postulate. Next, find the that's an arrow. Find the value for x, which makes A parallel to B in this diagram. Well, if I'm trying to get these lines to be parallel, I must know something about this 62-degree angle and this one right here. What's the name for the relationship between this angle and this angle? Same side, interior angles. They're on the same side of the transversal, and they're in between the two lines that we hope will be parallel. So now, let's do the math. What's the relationship on same side interior angles? They add up to 180 degrees. That means I can substitute these things that I have right here in an equation. 62, there's one of the angles. 7x minus 8, there's the other one. First angle, second angle, add to 180. That's what supplementary means. So now let me combine my like terms. I get the 62, take away 8. That's on the same side of the equal sign, so I can combine them. And I'm left with 54 plus 7x equals 180. Subtract 54 from both sides, and I've got 7x equals 126. Divide both sides by 7, and x has to be 18. But I'm not done. what would the angle measurement be up here? Well, I can do the algebra with it. 7 times the 18, and then take away 8. Or you could have said, hey, you know what? If these are supplementary, then 62 plus the thing I don't know adds up to 180. Subtract 62 from both sides, and the angle that we didn't know that we had an expression for, 7x minus 2, would be 118. Which also happens to be the correct answer here, because 7 times 18 is 126, take away 8, and you're at 118. So there we go, x equals 18. So the angles are 118 degrees and 62 degrees. Great. Now go to the practice section.